Once we know how to graph inequalities in two variables, our next step is to graph systems of inequalities. So here's an example of such a question where we have two inequalities and we want to graph the solution set of these inequalities. So that's the set of points that satisfy both inequalities simultaneously. There will be some points that satisfy one inequality but not the other, and we want to visualize which points satisfy both. So the first step is, as with just one inequality, to graph the associated lines for each inequality. And this is a picture of that situation. The dark blue line here corresponds to the first inequality. The light blue line corresponds to the second inequality. And then for each line, we want to test a point to decide which side of the line to include in our solution. We're only going to end up shading the region that gets shaded for both inequalities. We want to shade the common solution region. For example, if we start with the first line, that's the dark blue one, plug in a simple point like the origin. 2 times 0 for x plus 3 times 0 for y evaluates to 0. That's indeed less than 12, which means the origin is part of the solution set for this inequality. That means when we're shading, we want to shade the stuff that's on the same side of the dark blue line. So everything that's below the dark blue line, because that's everything that's on the same side that the origin is. So then we want to check the second line, and if we plug the origin into that, again, it satisfies the inequality. So similarly, we want to shade everything that's below the light blue line that corresponds to the edge of the solution region for this inequality, x plus y less than or equal to 4. So we're shading everything below the light blue line for that, and everything below the dark blue line for the first inequality we worked on. And if I'm only going to shade the points that get shaded both times, then I don't shade this region because those points are above the light blue line. I don't shade this region because those points are above the dark blue line. And I don't shade this region because those points are obviously above both blue lines. I only want to shade the points that are below both lines because the origin, which is below both lines, satisfies both inequalities. So I want to shade all of the points down here. And this is what our final graph would look like. Let's look at another example. Again, we have two inequalities. I'm going to graph the lines that correspond to the boundary of the regions that satisfy those inequalities. And then I'm going to test a simple point and shade the common region satisfying both inequalities. So we start with x plus 2y is less than or equal to 8. That's in this picture, the dark blue line right here. I'm checking the origin again, and I'm seeing that that's true, that when I plug the origin in, I satisfy the inequality. So I want to shade everything that's on the same side of the dark blue line that the origin is. So that'll be everything below the dark blue line. Now when I move on to the second inequality and I check the origin, I get something that's true. So again, the origin satisfies the second inequality. I'm going to shade everything on the same side of the light blue line that the origin is. The origin satisfied the first inequality, so I'm going to shade everything that's on the same side of the dark blue line that the origin is. And we can see the points that get shaded both times are the points in this left side region, which means the graph of our solution set looks like this. Let's look at one more example. So this is almost the same as the previous problem. The only change I've made is right here. This inequality is facing the opposite direction. In the previous problem, it looked like this. So what does that mean? It means when we graph the lines that are the edges, we get the same edges. And when we start to test the points to decide the region they have in common, we again end up shading the side of the dark blue line that includes the origin. Everything below the dark blue line satisfies the first inequality. But when I plug the origin into the second inequality, I get something that's false. So I don't want to shade the side of the light blue line that contains the origin. I want to shade the other side over here. Now remember, I was shading everything below the dark blue line, and we can see that the region that gets shaded both times is this, right here. So that's the final answer, that shaded region. One more example. This time we have 4 inequalities. So what we're going to have to do is graph 4 lines. Now notice that the edge of x greater than or equal to 0 is the line x equals 0. X equals 0 is the same as the y-axis. So that's the red line we see vertically here on top of the y-axis. Similarly, y equals 0 is the x-axis. That's the yellow line we see right here. We run into these inequalities a lot, x greater than or equal to 0, y greater than or equal to 0. And so it's worth remembering that their edges are just the coordinate axes. Okay, we'll test. So this should actually say x plus 2y less than or equal to 6, not 8 here. So when we check that, that's the dark blue line here. If we plug in the origin, we see that it satisfies the correct inequality. So we do want the origin. That means we do want everything below the dark blue line. Again, these should be 6s, not 8s. And then when we check the second inequality, that's the one corresponding to the light blue line, we're going to have the origin satisfy it. So we want to shade what's below the light blue line. We also want to shade everything where x is greater than 0, that's to the right of the red line, and everything where y is greater than or equal to 0, that's above the yellow line. So when we remember that we're shading below the dark blue line and below the light blue line, what region gets shaded every time? Well, we need to stay to the right of the red line, above the yellow line, and below the light and dark blue lines. So that's the region in here. That's our solution set.